Hi students, now we are going to have a quick revision of all kinds of numerical problems in the chapter electricity. Okay, so the first sum is the current passing through a room heater has been halved. Okay, if I ampere is halved means it becomes I by 2. So what will happen to the heat produced by it? This problem can be solved by using which law, you tell me? Yes, it is Joule's law of heating. So according to Joule's law, okay. So according to Joule's law of heating, the expression is given by heat produced H is equal to I square into R into T joule. Okay. This is the expression we are going to use. If the current is halved, if I becomes okay, I by 2. So if I is halved, that is it becomes I by 2, then the heat produced, I will take it as H dash. So H dash is equal to I by 2 the whole square into R into T. So this is equal to I square RT divided by 4. So this is equal to H by 4. So this is equal to H by 4. Therefore, the heat produced, okay, heat produced is becoming what is becoming 1/4. Okay, is 1/4 of 1/4 of the initial heat H. Understand? Have you understood? Okay. Now the second problem also is based on Joule's law of heating only. An electric iron of resistance 20 ohm is given. It draws a current of 5 amperes is given. So calculate the heat produced in 30 seconds. Direct application of Joule's law. So what are the given quantities? R is equal to 20 ohm and current I is equal to 5 ampere and time is equal to 30 seconds. So this is 30 seconds. So heat produced is asked. So what is the heat produced? Is given by Joule's law. So what is the expression for Joule's law? H is equal to I square R into T. So this is 5 square, okay, 5 square into R. R is 20 ohm into T is 30 second. So this is equal to 5 5s are 25 into 20 into 33 2s are 6 and remaining 2 zeros. Okay, now 25 into 6 is 150. So this is 150 followed by 2 zeros. So this is the answer, 15,000 joule. Now 1000 joule also is equal to 1 kilojoule, is it not? So we can also write in kilojoule. So the heat produced H is equal to 15 kilojoule. That is the answer. Okay, so what is the statement we are using here? The heat developed in a current carrying conductor is equal to the product of the square of the current flowing through the conductor and the resistance of the conductor and the time of flow of current. I hope you have understood. Fine.